don't worry about much about the circuit diagram. Okay, first understand the process, that is important. Okay, so what is interface circuit? What are the functions of interface circuit? We have discussed in the yesterday's class, and also we have discussed about the parallel port. Okay, so how this parallel port works? See, many of the things in this diagram you are already familiar. Just explain with respect to, if it is keyboard, it is read operation. Okay, if they ask for explain the interface diagram with respect to processor and keyboard, you need to just draw this block diagram. Okay, if they ask for block diagram, if they ask for interface circuit, then you have to draw this. Okay, if possible, you try to remember this diagram, how it like working procedure is very simple. Okay, they have not given in detail, but you need to try to draw this diagram if they ask interface circuit for input, or if they ask for the interaction between the processor and keyboard. So you need to just explain about the procedure, like how exactly the read process takes place. Okay, so we have discussed about this parallel port for read, and this is for write operation between the processor and printer. So normally they'll ask these type of questions. So I think I have not given the questions on this. Somebody is unmuted. Mute yourself. Okay, and the corresponding interface circuit for output operation. This one you don't read also. You just skip it. That is combined one. So next we'll move on to the serial port. Okay. So yesterday I already told what do you mean by serial port and parallel port with respect to the data transmission. Okay, so serial port where it is going to transmit the data one bit at a time. Okay, in the serial manner it is going to transmit the data. So in that case, so how the data transmission takes place, and also we have discussed that in the interface there will be a converter if device is supporting for parallel transfer. Okay, and if your device is supporting for serial manner, in that case it requires the converter. So IO interface will take care of conversion serial to parallel mode. So serial port is used to connect the processor to IO devices that request transmission of data one bit at a time. Okay. So serial port, example for serial port, you can just give example whatever the data that is transmitted using keyboard. Okay. So it is an example of serial port. So serial port communicate in a bit serial fashion on the device side. Okay, you just understand this point. So whenever if you're entering the data from keyboard, it is going to be transmitting that data to the bus in the serial manner. Okay, not exactly directly to the bus, there will be an interface. Okay, now whatever the bits it is transmitting, it will be sent in the form of bits and it will be stored in the interface circuit where it is having the buffer. Okay, the storage. So it is going to store that complete information, then parallelly it is going to be sent on the bus. Okay, so for that reason I told the interface is going to take care of the conversion from serial to parallel mode. Somebody is unmuted, mute yourself. Okay. So now we'll go to the diagram, the interface circuit, how it works. Don't worry much about the diagram. Okay. So you should be knowing what and all each of these signals, what is D0 to D7. Just remember those things. So D0 to D7 indicates it is an output line. Okay. So it is an output line. So now consider I am just trying to enter the data from the keyboard. Okay. So it is going to send that information in the serial manner and it is going to be collected whatever the data or bits I am entering. Okay. It will be stored in the register. Okay. Input register it is going to store. Input shift register it is going to store all the bits. So once it receives at least 8 bit of information, then it will be sent to data in. So shift register means it will receive only one bit at a time, 1 0. Okay, it will just collect it, and at a time it will be transmitted to data in. It is in a buffer storage with respect to the input device. Okay, it will be available in the interface. Then from that it is going to be sent through the output lines, that is represented D0 to D7. So I have already explained how the input and output operation works. Accordingly, it is going to make use of these signals and the operation is carried out. So that is input shift register accept one bit at a time from IO device. Okay. So that is the first step. First step for serial port. Then once all the 8 bits are received, that means it is going to just keep track of all the 8 bits. Okay, once 8 bits are filled in this shift register, then what happens, it is going to load that 8 bits information into the data in register. The content of input registers are loaded in parallel. That is important. All 8 bits. Okay, you will be having here D0 to D7 lines. Okay, so all the bits at a time, parallelly means at a time all the 8 bits will be loaded into data in. Now from data in, okay, the output of data out register are loaded into output shift register. Okay, so whatever the data that comes from data in, it will be sent to data out, and from data out it is going to carry through the processor bus. Okay, so it will be carried through the processor bus. Okay, that is represented with D0 to D7. This is the data lines associated with the bus. Okay, now to control this operation, read and write operation, so we need all that information, that is where it requires the address lines. Okay, where it requires the control lines. Okay, control line indicates even either is it read, write, or is it the device is ready or not. All that information it is controlled by sending control signals. And also whenever if the device, if it is not ready for performing either read or write operation, okay, so the corresponding information it should be set in the status flag. In case if the device is having some valid data, even that device can send an interrupt signal to the processor indicating that it is having some valid data in the data out register. So that is how this serial port works. Just remember here, the operation is very similar to the uh, previously whatever we have discussed, parallel interface. It is very similar to that. Only thing is, so this part, the beginning part, it is going to be changed. Here it is going to read the data in the serial manner, collect all 8 bits at a time. Parallelly, it is going to send the data to data in register. Okay, so that is just explain in brief how this serial port works. Okay, so next we'll move on to the standard IO interface. So what are the standard? Do you think now, as I think from 3 to 4 class, I'm using the term called bus. Do you think only it is having only one type of bus? No, there are different types of bus depending on the requirement, like how fast the data should be sent, how much data, that is the bandwidth of the bus. Based on this, they have categorized into different types. Okay, and what type of device you are going to connect? If you are connecting slow speed device, okay, where it can transmit the data at slowest speed, then it will be having different device, different bus to connect those such type of devices. So how it can be categorized? Okay, so here a personal computer has motherboard which houses processor chip, okay, processor chip, main memory, and some IO interfaces. Okay, normally I think that is a basic diagram we have discussed so many times. This bus we call it as processor bus. Okay, where the processor and main memory, this is called processor, okay, and this is called main memory, where these two are connected directly to the processor bus. This is the main bus. Now the remaining IO devices may be connected directly depending on their characteristics, or it may be connected using other type of bus. So what are those other types of bus? So that we are going to discuss in standard IO interfaces. So there are mainly three types of buses. One is called PCI, and the second one we call SCSI, and the third one we call it as USB. I think USB port everybody knows, no? So that part, what type of device you can connect, so that we are going to discuss here. Okay, so what are these three types of buses? One is PCI, I told, peripheral component interconnect. See, this is like one compulsory question you will be getting, 10 to 15 marks. Okay, the questions I will be sharing later. Okay, 10 to 15 mark question either on PCI or SCSI and USB port. Okay, USB bus. So you should be able to explain how these interfaces, the bus interfaces, it is going to work. So we'll be discussing the first one called PCI bus. So that is the main bus is, you need to remember where it is connected the processor and main memory. Okay, the remaining devices are not connected directly to the processor bus. This is the processor bus. Remaining devices, example keyboard, okay, disk, mouse, whatever it is there, these are all not connected directly to the processor bus. So here it is going to use one more type of bus called PCI bus. Okay, you can just observe in the diagram. So this is called as processor bus. Okay, the processor bus, so that is going to bridge the connection between the this processor bus and other devices are connected using PCI bus with the help of a special circuit called a bridge. So this is a circuit called bridge that is going to connect the processor bus and PCI bus, and this PCI bus is also called expansion bus on the motherboard. So this and all, it will be these components are available on the motherboard. Okay, if you just whenever if you have seen the what like how the motherboard works, you can see all this bus part. Okay, where there will be one processor bus followed by, you can see there are so many other connections, small wires, so that is going to indicate the PCI bus. Okay, so you cannot connect this PCI bus directly to the processor bus, where it requires the a special circuit called bridge. Okay, so that is going to interconnect the processor bus and PCI bus. Okay, so just remember what is PCI bus, what is processor bus, and how these two are connected, and these two are connected using expansion bus. Okay, so PCI, this bus we call it as processor bus, and PCI bus is also called expansion bus. That means it is going to expand to connect many other IO devices. Okay, and this PCI bus, it has to be connected to the main bus, but it is not directly connected, it is connected through the bridge. Okay, so it is connected through the bridge. Now what is bridge here? So bridge circuit translate the signal and protocol from processor bus to the PCI bus. See, it is having some set of characteristics. Okay, and PCI, it is having its own set of characteristics. It is not matching with this processor bus and PCI bus. You cannot, that is the reason you cannot connect directly. Now that conversion, it is going to be taken care by this bridge circuit. Okay, so that is why the bridge circuit is required. So now we'll just try to discuss. You can see here, one I told PCI bus, and the second one is SCSI bus, and the third one is USB bus. So we'll discuss all these three types one by one. We'll start with the PCI bus. Okay, that is, you need to remember, it is peripheral component interconnect. Just note down peripheral component interconnect. So SCSI indicates small computer system interface. Then USB indicates universal serial bus. Okay, so now before going to the working procedure of PCI, so we'll discuss what are the characteristics of PCI bus. Okay, what are the important characteristics of PCI bus? So PCI bus is mainly uh, developed for low cost bus. Okay, and this is truly independent of processor. Okay, it is not going to be dependent on like independent of processor. Any type of processor can be connected using PCI bus. So one is the important characteristic. It is introduced in 1992. Okay, that is the development when they have introduced this PCI bus. And what is the speciality of this PCI bus is it is low cost. The cost involved for this PCI is very low. Okay, and it is going to work with any of the processor, any type of the processor. That's why it is called processor independent. And it is having one more capability or flexibility, we can call plug and play capability. So as and when you need this PCI bus, you can just connect the device to PCI bus and perform the operation. If it is not required, you can just unplug it and you can remove from the PCI bus. The devices can be easily attached and it can be removed. So that capability it is supported by PCI. Okay, just remember those important characteristics. So that is today's computer, most memory transfer involves burst of data rather than just one word. Okay, so we have already discussed just transferring one word of information. It is different from transferring block of data. Okay, we have discussed how this transferring technique can be used. Okay, during discussion of interrupt and also DMA. Whenever if it requires to transfer large block of data, so where it requires to go for a DMA. Okay. So now, before going to the working procedure, what and all signal it requires to work with the PCI bus. So always remember the bus supports three types of address space. So one we call it as memory address space. So that is to store the data or information, memory address space with respect to memory address. Okay, maybe the address is with respect to IO device. For that also there will be a separate address space. Okay, and the third one is, so that is for configuration. So configuration address space. Okay, so bus supports these three different independent address space. With respect to memory operation, it is going to use this address space, means it is nothing but memory. Okay, it will be having memory part. This bus is going to have memory part that where it can store the, I mean it can hold the memory addresses. Okay, and another set of address space that is with respect to IO device. See, we have already discussed what is bus. It is set of lines. Okay, so those lines can be categorized into different types, that is to carry the address, data and control information. Okay, that's what I am just explaining with respect to the address space. Okay, so now how this PCI works. Okay, how this PCI works, let's assume some of the important points here. So we assume that master maintains the address information. So here you need to know there are two terminologies we are going to use. One is called initiator. Okay, in PCI, when you are learning about the PCI, you should be familiar with some of the important key terms called initiator and target. We have already familiar with master, the keyword master, who is the master of the bus. Okay, whichever the device that uses the bus at that particular time, so that particular device is going to be the master of the bus. Okay, so here we assume that master maintains the address information on the bus. Okay, master maintains the address information on the bus until data transfer is completed. Yesterday I explained, no. So if all the IO devices are connected to this bus, so till the device reads the data, okay, till the device reads the data, it has to hold all the information including address, data and control information. It has to keep that data on the bus. Okay, so that is, it indicates the propagation delay, how long it is going to take time to get the data and stored into input device, output device buffer or input device buffer. So such a long time, the address and data information should be available on the bus. It is not like that it's simply coming and going. Okay, it should be there on the bus for some amount of time. Okay, so the data should be available, address should be available till the IO devices read or write the data onto its storage, that is the buffer. Okay, so here we are going to assume, instead of that what we can do is we are going to assume that the address is needed. Okay, just concentrate here. I'm just assuming some particular point here, that is the address is needed as long as the slave is selected. Okay, consider processor is requesting data by the input device. Okay, what it will do, it will send the address of the device and control information. Okay, or consider if it is performing the write operation. If it is write operation, it requires address and also what data to write to the output device and control information. Now if all these three information are available on the bus, okay, is it just think, is it necessary once the slave is identified, consider the slave is identified, it is matching with this address. Okay, is it necessary to hold the address on the address bus as long as the device is going to read the data? It is not necessary, no, it is just an assumption. Okay, so it is just assumption that we are going to consider that it does not require to hold the address on the address line once the slave is get identified. Okay, so the address is needed as long enough for the slave to be selected. Okay, as long as the devices get selected, address is required. After that, address is nowhere required. Okay, the device, it is going to place the data onto the bus, or it is going to get the data from the bus. Okay, depending on read or write operation, it will perform. So approximately we can tell that the address should be available on the bus only for one clock cycle. Okay, afterwards the address line can be, assuming that in that one clock cycle the device is, it will be identified, the slave is going to be identified. Afterwards address is not required on the address bus, it will just remove that address. Okay, it will just free from that particular address on the address line. Okay, so now why I'm just telling about this address to free up. Okay, I'll just explain that. You will come to know why I made this assumption. See, once if address is freed, so that particular slave, it is going to either perform read or write operation. So during that time, the processor can start fetching or processing one more request. Okay, so how it is going to do that, we'll just discuss in the diagram. Okay, and here I told there are two terms I'm going to use. The master is called as an initiator. Okay, the master means who is going to request the operation, either read or write operation. Okay, so that becomes the initiator in the PCI terminology. In the arbitration process, we have used the term master. Okay, that is the only difference. The address device, that means the master who is going to request for a particular device, no, so that device we call it as target. We call it as a target. Instead of slave, we are going to use the target. Okay, just remember, master is nothing but initiator in PCI bus, and slave is nothing but target. Okay, so that is the only difference you need to remember. Now onwards, I'm going to use to explain the read operation, how it takes place on the bus using PCI, using initiator and target. Okay, so initiator means master and target means slave. Okay, so now to understand how this PCI works, so you should be familiar with these signals. Okay, so I know it may be a little bit difficult in the beginning to remember all these things, but you have to remember. Okay, there is no other choice, because normally you will get a question on PCI bus. So if they ask, explain how read operation takes place on PCI then your hertz clock. Okay, so that is a clock rate. Okay, either 33 or it may be 66. Then we have one more signal called frame number. Okay, frame. So sent by the initiate to indicate the duration of transaction. Okay, so this frame number indicates so how long that particular initiator, that is the master, it requires to perform the transaction. Transaction means here data transfer. Okay, so how long it is once again represented in the form of clock cycles. Next, AD. So AD indicates it is an address. So what is the address size? Normally it is 32-bit address line, or it may be data line. So which may be optionally increased to 64. Okay, but we are discussing 32-bit address in all the topic. Let's consider only 32-bit address here. Then we have another signal called C/B hash. What it indicates? So C indicates the command. Okay, C indicates the command, and B indicates byte enable lines. Byte enable lines, that is 8 for 64-bit bus. Okay, so in terms of byte, if it is 32-bit bus, then you will be having 4 bytes. So now if you are considering 32-bit, okay, you will be having 4 byte enabled lines you will be getting for transferring the data. So one indicates the command, and BE indicates the byte enabled lines. How many byte enabled lines are existing? Then we have IRD, then Y, TRD, Y. So what is this? Very simple. So IRDY indicates the initiator ready. Do you remember we have discussed master ready? Similar to that in PCI we are using IRDY, initiator ready. Then TRDY indicates target ready signal. Just you can correlate the concept whatever you are learning in the previous topic and PCI. It will be easy to understand. Okay, initiator ready and target ready. Whenever the master, so here called initiator, places address and command information on the bus, immediately it will activate this signal indicating that it has placed the address and command information on the bus. So immediately the target is identified. If it is responding to that particular command, then it is going to place the requested data and it will initiate the target ready signal to indicate to the initiator that the data is ready on the bus. Okay, just relate master ready to initiator ready, slave ready to target ready. Then we have another signal called DVSCL, that is device select, a response from the device indicating that it has recognized its address and is ready for data transfer. Okay, before sending target ready signal, as soon as the address is placed by the initiator and if it is get matches with any of the device, that particular device is going to send the signal. Okay, then we have, I'm just explaining about the signal. Later I'll explain how to use these signals. Okay, then we have one more signal called, actually here I have noted, okay, here it is there, TRDY, and there is one more signal called IDSCL, that is initialization device selected. Initialization device selected. Just remember. Okay, so now when I am explaining about the PCI read operation, I am going to use all these signals to indicate the operation. Okay. Let's go to the read operation. Okay. Now in case if PCI bus is, the devices are connected to PCI bus. Okay. For read operation, how it works. In this diagram, we have already discussed about the processor bus in the previous topics, DMA, okay, and also in the synchronous asynchronous bus, how it works. That explains about the processor bus. Once again, I am not going to touch upon this processor bus. We are going to discuss what are the other type of buses are used to connect to this particular main bus or processor bus. Okay, in that we have selected the PCI bus. It is also called expansion bus on the motherboard. Now, okay, don't just listen what are the steps I am explaining. Okay, just listen to what are the steps I am explaining. I'll just explain this diagram with respect to the clock cycle. Okay, how many clock cycles are here? So there are 7 clock cycles. Okay, and here it is going to perform the read operation. That means initiator is going to try to get the data from the particular device. Okay, example keyboard. It is the processor is going to get the data from keyboard. So in that case, how PCI bus works? Okay, so we'll start with the clock one. What happens? Just observe. I am going to explain in terms of the clock. Each clock, at each clock, what is the step it is going to take place? Okay, during clock one, you can just observe what has happened here. So during clock one, the processor asserts frame. So this is a signal frame hash indicates the beginning of the transaction. It is going to tell that it is going to begin the transaction. That means it is going to begin the operation. Okay, for that it is going to send this signal over the PCI bus. That is the first operation, and also at the same time it is going to place the address on the address line and also command on the command line. Okay, so address and command it is sent through the respective address lines, and it is going to send this frame signal indicating that the initiator is started the process. Okay, that is in the clock cycle 1. Next we'll go to clock cycle 2. Clock cycle, so now this part is done by the initiator. This is also sent by the initiator. This is also sent by the initiator. Okay, next during clock cycle 2, okay, during clock cycle 2 what happened? So clock cycle 2 is used to turn on the address address bus line around, and processor removes the address and disconnects its drive from the address line. I made an assumption that so address is not required for long time. Okay, it can be there for one clock cycle. By that time the device will be identified. Okay, I am just assumed that. So during clock cycle 2 what happened is, so whatever the address it is placed on the address line, it is going to remove that address information from the address line. Okay, it disconnects the address because now by clock 1 the particular address device is identified. Okay, that is I have just assumed in that way. Then so the selected target by this time clock cycle 1, so the particular device that is matching with this address it is identified. Okay, so the selected target enables the drive on address line and fetches the requested data to place on the bus. Okay, so now the addressed device is going to be identified and it is going to place the requested data on the data line. Okay, it is going to place the address on the data line. So how it is going to place this, or how it is going to inform this information to the initiator? Okay, how the target device is going to indicate. So that is done by asserting, like how initiator is sent frame before sending address and command line. Similarly, before placing the data, the target device, okay, the target device, it is going to activate this line, okay, and maintains it. It is asserted till the end of transaction. This particular line it is going to be active as long as the data transmission is completed. Okay, as long as this data transmission is completed. Okay, that is the first step done by the target address. Okay, now this C/B, that is command or byte enabled, used to send the burst command on clock cycle. It is used for different purpose during the rest of the transaction. Okay, it can be used for initially till clock cycle 1. So it will be indicating what operation to perform. After that, these lines can be used for some other purpose. Okay, for some other information transaction. It is not going to be retaining that command information for long time, both address and command. It will be there only for one clock cycle. So by that time, assuming that the target device is identified. Okay, and also it is asserted a signal indicating that the target is selected. Now we'll go to clock cycle 3. So what happened in clock cycle 3? So now initiator assert, okay, assert means it is going to activate a signal called IRDY. So that indicates that the initiator is ready to receive the data. Okay, after placing all this information and the target device is selected, so initiator is going to activate this particular line indicating that it is ready for receiving the data. Okay, so who is telling this? This is indicated by the initiator who requested the data. Okay, now if the target device is ready for sending the data at clock cycle 3, okay, so the target device, if it is ready for sending the data at clock cycle 3, it is going to assert a signal called TRDY. Okay, it is going to assert the signal called TRDY. That means it is the target device is ready for sending the data. Okay, and the data you can just observe, it is placed, that is 1 2 3 4. Okay, 4 bytes of information it is sent using this address line. So that is the reason I told, so why we are going to place address only for one clock cycle. Okay, remaining part of the time that can be used for some other transaction I told. So now the selected target device, it is going to transfer the data using these address lines. Okay, so that is all how it works. And at clock cycle, the clock cycle 3, 4, 5, 6, it is used for transferring the data. It is used for transferring the data. And at clock cycle 7, what happens is, okay, it is going to assert a signal called, okay, it is going to assert a signal called device selected. Okay, actually assert means deactivate. Okay, it was active actually here when the target device is identified, it is activated this. Okay, it was active. Now at clock cycle 3, during that time the data transmission is completed, it is going to assert back to 0 or disable. At clock cycle 7, it is going to disable this line indicating now the target device is completed the data transmission. Okay, so this is how the read operation takes place on the PCI bus. If they ask, you should able to just make use of these signals, draw this diagram, explain in your own words. Okay, so how initiator is going to place the information and request the task, and how the target device is going to respond. Okay, just read once, you will understand. That is about the PCI. So many times they asked about the read operation on PCI bus. So you just explain in your own words about the few characteristics, the first 3 characteristics. Okay, and just mention what are the important signals are used on PCI bus, then followed by this diagram. Okay, so I'll just skip this part. So here this slide, it indicates that, so why we are not connecting the PCI bus directly to the processor bus is, that is due to some electrical characteristics. Okay, we are not connecting all the devices directly to the processor bus. It should be connected through PCI, that is expansion bus. Through bridge it is connected to the main processor bus. Okay, that is due to some electrical characteristics. So electrical characteristics indicates the speed, the voltage used, all that matters. Okay, so because of that, this is not connected directly, it is connected with the help of bridge. So next we have the second type of bus, that is called SCSI bus. Okay, I don't know how many you feel it is difficult, but it is not difficult. Just read once, you will understand. Okay, so the three standard type of buses. So in that we are discussing the standard IO interface bus is PCI bus. Okay, you can just observe what and all devices are connected to this PCI bus. Okay, where you can see the disk. Okay, disk control, disk controller. These are all like a high speed device where it can transfer the data, large data. Okay, for such device you are going to use SCSI bus. Okay, these are all once again not connected directly to PCI bus. So that is how the devices are connected with the different types of standard buses, bus interfaces. Okay, that you need to understand. So now we'll just focus on how this SCSI bus works. What type of devices can be connected to SCSI bus. Later we'll go to the USB. And USB, normally you will use USB bus for connecting the keyboard, okay, mouse, and any game related devices. You are going to use the USB controller or USB bus. Okay, so you can just see the USB cables. I think pen drive, how you are connecting your pen drive. Okay, through USB port you are going to connect the devices. So do you think when you insert your pen drive, is it directly connected to processor bus? No, you can just understand that it is connected to USB controller, then PCI bus. With the help of PCI bus, it will be connected to processor bus. Okay, always the processor bus is, that is the main bus, and that is connected with processor and main memory. So remaining all, it is connected with the help of standard IO buses, bus interfaces, that is PCI and SCSI. So next, I'll just move on to the next type of bus. We'll just discuss in brief, and later we'll discuss. I think fourth hour I'm going to take one more class. Okay. So what is this SCSI bus and where you are going to use? What are some of the electrical or important characteristics of this bus we are going to discuss? That is indicating small computer system interface. Small computer system interface. Okay, it is introduced by ANSI. And what are the characteristics with respect to this bus is the original specification of the standard device which has disk are connected to the computer via even the wire length. Okay, so what should be the wire length to connect the devices to this bus is, so here it is 50 wire cable. Okay, so which can be connected up to 25 meters in length. That means the connection between the device to the bus, it can be up to 25-meter in length. Okay, and data transfer rate on this bus is 5 megabytes per second. Okay, just remember this. What is the data rate on SCSI bus is, data rate, it is 5 megabytes per second. And what is the length of the bus? Length of the that wire or the bus, it can go up to 25 meters. So here SCSI bus standard has undergone many versions. Okay, so now whatever we are using, it is like there are so many versions and there are so many improved versions. We are whatever we are using, those are all having different versions. Okay, maybe currently we are using SCSI 3. So 1, 2, 3. Each time there is some improvement it is done with respect